Okay, cool. So now we're going to be talking about PWM. So from the last video, like I just said, we're starting off right where we ended with that video. So we have our timer and it's doing this this sort of behavior. It's counting up and then counting down. And you can see it here on my output screen how it's counting up. Now it's going to count down. So it's doing this sort of behavior. But for PWM, you can use it in this mode too, but I'm gonna go ahead and I'm gonna set it back to the regular mode where it's just counting up. That means this guy's gonna go away. That means we're gonna leave the direction bit to default right here, so we can have an up counter. Okay, so here's how PWM is gonna work. Here's the base. I'm gonna give you the basic of how it's gonna work, and then we'll get more into the what the actual bits and things that we have to set, right? So we're gonna be using counting up, okay, and this is how it works. Remember, there's 4 channels, so I'm gonna be using channel 4 on timer 4. So this right here is the capture compare register 4. And that is right here. See, these are the 4 different channels that can output 4 different things for the same exact timer, right? And we're gonna be using this one. Oh, here it is. Timer capture compare register 4. And that's because I'm using channel 4. And again, channel 4 is going to output on port B9. Timer 4, channel 4. Okay, again, you can choose any timer or any channel you want, but that's just what I'm using here. Oops, where's my, there it is. Okay, nope, not what I wanted. So this is how this is going to work. So as you recall from the previous video, your timer, your counter is counting from 0 up to whatever value you have here in the ARR register. So what happens is that you have this you have one of these for every channel. So let's say, for example, we set channel 4 to compare register to equal 5. So what's going to happen is that our PWM output is going to be like this. We're going to have a high input so long as the timer counter, this value right here, is less than this value that we have here, right? So you can see right here we have this high output during the entire time that this value is less than this value. Once it becomes equal to that value, our PWM signal goes down, and we're going to be down for the rest of the time until, again, timer counter, which is now 0 at this point, into timer counter is less than channel 4 value, right? So this is the PWM signal that you're going to get on your output pin. So as you can see, if I were to set channel 4 to something like 2, that's right around here, that means we would be high up to here, right? Up to here. And then we would be low for this rest of the time. So then we'd have basically a smaller duty cycle. So as you can see, that tells me that this controls my duty cycle, okay? Because 0 is here, and whatever value we put here, even if it's 0, I mean whatever value this is, it's always going to be, for example, if I put 0 here, then we're just going to get a flat line, because timer counter and these they're going to be equal, and when they're equal, the signal drops, right? So we're going to get this flat line. If I set this counter register equal to the value of whatever is up here, right, at this register, then what we're going to get is also a flat line, but at the high value, right, up here. And if I set this to the middle, whatever, the point is that this right here controls your duty cycle. This sets how wide your high part is, okay? And this right here, as you can see, it controls your frequency. This is how often this is happening, right? Along with the prescaler, obviously, but for the most part, you're not going to be changing your prescaler all the time, or you're gonna, well, both of these are going to be fixed for the most part. So this basically right here controls the frequency of your PWM, and then this register right here controls the duty cycle of the PWM. Now if you take a look at our data sheet, that's exactly what they tell us. If we go to functional description, let's go to PWM mode. So it tells us that we have to, that the frequency is determined by the value of the ARR register, like I just said. It doesn't mention the prescaler, but that's pretty obvious because, well, it just does, according to the last video, right? And the duty cycle is determined by the value of the CCRX register, where the X corresponds to the channel that you're working on. Okay. One thing about the channels, before we get to this part, which is also important, if you look at your registers, here's register 1, 2, 3, and 4. These correspond to your different channels. So whatever value you're going to put, let's say you can have a PWM frequency with a duty cycle of 50%, right? And on channel 4, and then you can have another one on channel 3 with a different duty cycle. They're all going to have the same frequency because the frequency is determined by this, and there's only one of these. So all your channels are going to have the same frequency, but you can make them have different duty cycles because the duty cycles is dependent on this register, and there's 4 of them, one for every channel. And every channel is a different pin on your microcontroller. So you can have 4 different PWMs, same frequency, but different duty cycles, okay? And this is the registers for your 4 different channels. Now, there's other things we have to set. It's not that easy, right? It says PWM mode could be selected independently for 1 PWM channel per output compare output by writing a 110 or a 111 into the OCM bits in this specific register. So now this is telling us that we can select either PWM mode 1 or PWM mode 2 by writing to this bit in this register. So let's go to this register and look at that. And I like to have 2 data sheets open because I don't want to lose this page. So here's another copy of the data sheet where I'm going to go to that register. Okay, so CCMRX right here, CCMRX, and there's actually 2 of them, MR1 and MR2. Now if you notice here, it's a 16-bit register. This half from bit 0 all the way up to here, here, this is all one channel. As you can see how it says CC1, OC1, OC1PE, OC1M, 1, everything here has a 1 in it, okay? IC1F, IC1P, so that means channel 1. And then over here, this side is identical to this side, but this is all has the number 2. Everything's with 2. So this is for your channel 2. So then we have this other register, which is the same name, but has the number 2. Now this register has everything with a 3 and everything with a 4. So obviously, if we're working with channel 4, then this is what we're going to be setting. Okay, these are the settings that we're going to be concerned with. And there's not much description here. If you go here, for example, the OC4M, it says output compare mode. Okay, but it doesn't tell us what to set, like what mode, how can we set it, because it all describes it for it only describes it for this first one. It only describes it for channel 1, and you just it's obvious that, okay, the same will apply to the rest of the channels, the same settings, because all the registers are identical. So if we look at the description for channel 1, we go back here, it says that we can select our PWM mode by looking at these bits, the OCM bit, OCXM. So we're going to be looking at OC1M to read info, but in reality, in our code, we're going to do OC4M. So OC1M, it tells us here that a whole bunch of other stuff, but what we're concerned with is that we have this here, PWM mode 1 and PWM mode 2. Jesus. Okay, so PWM mode 1 tells us this. It says in upcounting, channel 1 is active, keyword active, as long as the timer counter is less than the control register 1. So in PWM mode 1, it's basically what I described here. This signal is active, so as long as this value is less than this value, right? That's all the data sheet is telling us for PWM mode 1. Where'd I go? That in upcounting, we're in upcounting, that's what I just showed you. Channel 1, or we're going to use channel 4, but that doesn't matter, is active as long as the timer count is less than control register 1. We're not, capture compare register 1. In our case, it's 4, or else it's inactive. PWM mode 2 is the inverse of this. In upcounting, right, it's inactive. So you see here, it's going to be inactive as long as that count is less than the capture compare register. So that's the only difference between PWM mode 1 and 2. In 1, you would have a behavior that looks exactly like this, that so long as this value is less than this value, we have a high signal. But in mode 2, it's the other way around, that so long as this value is less than this value, this signal will be down here, and then for this part it would be up here. So it's just gonna flip the wave upside down. That's all that does. Okay, and then let's go back here. Okay, so we have that. What else? It says the user must enable the corresponding preload register by setting blah 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 blah. Okay, so it says we have to enable this register. Must enable the preload register by setting the OCXPE bit and the CCMRX bit. Okay, so now let's look at this OCPE bits. OCPE, and we're gonna go to register 1 because that's where OCPE is bit 3. Output compare preload register. 0 means that the preload register on the timer counter compare register 1 is disabled, and that the timer control register 1 can be written at any time the new value is taken immediately. If you set it to a 1, it means that it's going to preload, right, operation, preload register, blah, blah, blah. Okay, what this basically means is that, where's the picture? When you have a value here, let's say you have a value here, right, and all this stuff is happening. If for some reason you change this value, if you have a preload register, which is exactly what it sounds like, you're going to change this value, right, on your code. You're going to be like, oh, CCR4 equals, 10. So you change it now from 5 to 10. But in hardware, it's not going to write it to here. Even though that's what your code says, in hardware, it's going to preload that value 10 somewhere in what they call shadow registers. It's going to preload it somewhere, and it's only going to put it into the actual register. It's only going to put it once we get this overflow event. Once it overflows, then it'll do it. So it won't allow you to do it in the middle of a counting operation here. So it'll only do it during that event. To your eyes, you won't tell the difference whether it did it here, did it here, did it here, or if it did it here. And for the most part, it won't matter. So we'll just follow the data sheet and we'll use that preload register, because again, we won't know the difference of where it did it. But that's all that means. It sounds a little more complicated. All it's saying, it's whatever value you're going to put in here when you're changing it during an operation, we're not going to put it there right away. We're going to wait for, for this to happen, and then we'll put it. And then your new value will be there. So that's all that says in that register, right? So that's the OC1PE. But remember, we're going to be using OC4PE in the other register, okay? What else does the data sheet say? And eventually, the auto reload preload register by setting RPE in the control register 1. So we're going to set RPE in control register 1. So if we go to control register 1, which is right here, and that's this bit 7, it says the ARR register is buffered. And that's exactly what I just described. Instead of putting our value directly to here and into here, the auto reload register is gonna do something where the hell is this damn picture going? Where it's gonna, I don't know how to explain it. It's gonna do this thing in sort of a buffer kind of thing, and once this actually occurs, then it all has to do with this when it's gonna actually do this. So it has to buffer whatever values we're gonna have left here until that that specific overflow event occurs. Then it's gonna go ahead and do that. And again, the data sheet is very obscure about what all this stuff does, or why you have to why you have to set these things. But at least that's what I can decipher from the auto reload, the preload register. At least that's what I can decipher from it. Okay, so what else? Oh, and I ended up changing my okay, so once we do that, it says as the preload registers are transferred to the shadow registers, like I was saying before, you get into these quote-unquote shadow registers, right? An update event occurs before starting the counter. The user has to initialize. So now they're saying that we have to initialize this UG bit into this EGR register. And or is this EGR bit, and that's that UG bit, UG update generation. You can go ahead and read that. I'm not feel like reading that, but anyways, they're telling us we have to set this bit. So let's go ahead and I do believe that's it. Yeah, okay. So now another thing we can do is change the polarity of our timer. If you go into this register right here, where are we? CCER. Okay, so here's the polarities for the different channels, as you can see, for whatever. So channel 1. So we can have inverted or non-inverted sort of signals by changing this sort of polarity. Now remember when we read up here in PWM mode, let me go to this datasheet now. Where did we do PWM mode? Right here on these, was it the OCM? Remember PWM mode 1, in up counting, channel 1 is active as long as, basically what we said was this, it'll be high as long as that this counter is less than this, it's high. Well, it's not really high, it's active, right? active could mean high or low. It's whatever we want it to be. So in these bits right here, notice how it doesn't say high. It says active and inactive. That's why I highlighted these, because you can actually change what active is. Do you want active to be high? Leave it as a 0. Do you want active to be low? Leave it as a 1. So the funny thing is that you can actually get the behavior of PWM2 mode by setting active to be low, and then this will be low, and then this inactive part will be high, low, high. So in essence, you can get PWM mode 2 by doing that. So if you leave it to default, you'll get this sort of behavior, which is the more I guess common way to use it, as active high, as most things define active as a high value. And one of the last things we have to do is going to be actually to enable the actual, so that's the polarity. And I don't know what all this, anyways, the point is that it's going to go here, and you see this bit 7. No, that's not it. Which is the, is it bit 2? No. I'm trying to find where the actual enable code is. Yeah, it is in that because you actually have to enable the yeah, 4PE enable. Yeah, I think I've covered just about everything actually. And then obviously you also have to do the whole timer enable thing in control register 1, this right here, because right. So anyway, so let's go ahead and get to that that part of the code. So now in this part of the code, we are using our GPIO. So in this so in this part, unlike the other one, we were just using this code. You do have to enable your GPIO B. I'm enabling GPIO A because I'm using that as my debug COM port. And your alternate function. Okay, that's very important, because if you don't do that, then your pin will not be connected to the timer. And then you also have to enable your timer 4, in my case, which is on the APB1 enable. Now you have to check what port, what register your specific timer that you're using is on. Alright, so if you use timer 4, it is on the APB1 bus. Now you also have to configure your pins. Your mode, we're gonna go in here and look at this real quick, because there's a little thing that it used to get me all the time, but now I think I'm getting used to it. Where the hell is my GPIO? There it is. Okay, so I'm using pin 9, so it's this right here, mode 9. So the mode you're gonna set to output at 50 megahertz, right? 1 So I have that right here. So I'm setting a 1 in the 0th bit of mode 9 and a 1 into the 1 bit of mode 9. And then I'm also setting the config. The configuration is output mode. We're going to use alternate function push pull. So right here you need to have a 1 and a 0, right? According to this right here, alternate function push pull. So you need to have a 1 and a 0. Now don't assume that these are 0 by default and then you just put a 1 here and then default 0 is already here. No, here is not a 0 by default. This is the reset state. This is the default value. So your default value is 0 and 1. So if you just put a 1 here thinking there's already a 0 here, you're going to actually have 1 1, which is this. It's not what you want. So yeah, you have to put a 1 here, but you also have to go in and clear this one. Okay, that's one part that used to mess me up a lot. So here I put a 1 into that config 9 1 bit, and I cleared the 0th bit. right, in the control register high for that. Now I'm gonna go ahead and paste the code that I have for this, because remember I already did this. Okay, so what I have here, let me put this, I'm gonna put this down here just so we can see all the numbers together. So given what our data sheet said, I did enable that ARPE bit. I went to the control register, and here I'm enabling the actual timer, and I'm also doing it here for some odd reason, which I should take these two, because these two things actually I want to do them last, because I don't want to enable the timer until I have all the settings in there. So let's see what I'm doing here. Back to our data sheet. So CCER, and this is, here's our timer. Where's our timer? CCER. Where the hell are you? Here we go. And what am I sending in here? CC4E, CC4E. Oh yeah, I think this is what I was looking for. I couldn't find it. The capture compare for. So basically this right here, bit 12 of this CCER output, the capture compare register, enable register. So these are your capture compare registers, right? These are your different channels. And this is the CCER, which is capture compare enable register. So this register actually enables these channels. So we have to go in and enable channel 4, which is this one. So we go to this register, and you go to here, CC4E, which is the output enable. So we're enabling the output on that 4th channel. So that's what I did in this line of code right here. And then I did that ARP thing that has to do with the shadow registers or whatever the crap was. This OC4M thing sets it into PWM mode, right? This is the control register. What the hell is my definition? So those 2 bits correspond to to this stuff, right? So I'm setting it the 0, 1, 2, the 1 and the 2 bit, the 1 and the 2 bit to set it into PWM mode 1, and then I'm setting this OC4PE, which means that the preload enable, which has to do again with that, the whole thing about preloading the value before it actually loads it here, right? So I'm enabling that. Oops, where's my code? So that's what that does. And then here's the prescaler. All right, so now let's see if our frequency calculations are correct. So my this should go here. So let's say we want a frequency of 1 kilohertz, right? And I know that my microcontroller is 72 megahertz, and I'm going to divide it by the frequency that I want. So I want 1 kilohertz. So 1 kilohertz right there. So that gives me 72 million divided by 1 kilohertz gives me 72,000. So I need to make it so that this and this give me 72,000. So what I can do is, cause I want this auto reload register to be a easy number to do duty cycle, because the duty cycle is nothing more than that register divided by the ARR register, right? Because, where's this picture? Your auto reload register, right? From 0 to whatever number you want there. Your duty cycle depends on this range, right? So if you have from 0, let's say, to 100, let's say you put 100 in your auto reload register, right? What's 50% of 100? Well, it's 50. So if you want a duty cycle of 50, you put a 50 here, right? So that's what I'm saying when I say that I want an easy number here so that I can find the duty cycles easily. If I put the number 535, well, and I want a duty cycle of 50%, well, what's half of 535? Off the top of my head, I don't know. That's kind of a hard number to find 50% of it, right? So that's what I mean. I want an easy number here where I could do duty cycles, where it's easy to find the duty cycle, right? So I hope you can see how this number relates to your duty cycle, because ultimately you're going to put a number here where we're going to stop our PWM signal, right? So if I put a number here like 1,000 and I want a 50% duty cycle, that means I'm going to count up to 500. So boom, 500, that would be 50%. So that's what I'm saying. I want an easy number here. So if I have to put, according to my calculator, 72,000, what I'm going to do is set that IRR to 1,000 and set this one to 72. So now when I do these two multiplied together will give me 72,000, which when I divide that and do the whole math thing, I'll have that 1 kilohertz frequency. And here we'll do, this is, what's 2, let's see, I think that's 25, right? So if I have 1,000, oops, and I do 25% of it, you get that value right there. So we'll have here a duty cycle of 25%, okay? Because this is 25% of that, and we're counting from 0 up to that value. So upload and upload, and right now it doesn't matter. I don't want to I'm not too concerned about the output of the count. Right now what I want to see is the actual signal. So we're gonna go here and this is a logic analyzer I have hooked up. So as you can see here, if you look up there, I can't put the mouse on it because it moves, but as you can see up there, it says a frequency of 985.5 hertz, which is about 1 kilohertz. And this logic analyzer may or may not be that accurate, so maybe an oscilloscope would be closer to 1 kilohertz, but that's about 1 kilohertz. And as you can see, the duty cycle says 24.98%, which is about 25%. So we'll just run that again. There you go, 24.98% and 985.4 hertz. Let me add 1 to this, see if that does anything, because 84, no, we're doing less. So I've put 999. I'm just trying to check because I know the actual okay, we're getting a little closer because I know the actual formula. Where is it? Damn data sheet. I know here I didn't account for the in my formula that I wrote down for you guys. Where are we? Prescaler. Here I didn't account for the if I could show you guys. Functional description. I'm trying to show you guys. I didn't account for the 1 in the nope, I don't know where the hell it is. In the prescaler in the prescaler thing here. But you guys can figure that out. Ugh, Jesus. I'm telling you, these data sheets are really something else. I can see why a lot of people have hard times with these things, and to be honest, I have a hard time too, and that's why I study these things a lot, and that's why I make these videos. I really recommend you guys to make these videos for yourself, because they say that one of the best ways to learn something is to try to teach it to someone else, because it forces you to put it into your own words and to explain yourself to see if you really know what you're talking about. And you don't even, if you don't like your voice, or you don't like the video, whatever, you don't have to publish it. It's on YouTube. You can make it private for yourself, and you just, when you forgot, okay, how is it that I do this, you go back and you watch your own video, and it's private and nobody else will see it. But it forces you to really say, okay, do I know what I'm doing? Can I explain it in a rational and coherent way? So that's what I try to do with these videos. A lot of times some of these concepts are new to me, and I try to explain them the best that I can. And the only difference is I do publish them, but I only do publish them once I feel like I've gotten a good grasp on it. So, well, that's gonna be it for this video, guys. So that's your PWM. So as you can see, if we put this back to 1000, you can vary. This will control your duty cycle. So right now we have that little duty cycle, 25%. If you set this to 750, you have a completely different duty cycle of 75%. And so you see, you have that 75% duty cycle. So yeah, so that controls your duty cycle. This, along with the prescaler, will control your frequency. And there you have it, guys. I hope you enjoyed that. If you have any questions or comments, please let me know, and I do reply, and I do listen, and I try to explain everything the best that I can. Alright, guys, enjoy, and let me know what else you want next. I will do a output compare and input capture mode for timers, just not today because this already took so long. Later.